Okay, 7th grade, today we're working on the surface area of cylinders. And we were working on prisms yesterday. And what do prisms and cylinders have in common? Think about it, a cylinder and a prism, they both have two bases, right? So in the case of cylinders, we have two circle bases, and the outside, the lateral area, that are not the circles, is a rectangular lateral area. So we can take a rectangular piece of paper and we can curve it around like the label on a can, right? And there we have the lateral, that's the side. Lateral means side, right? Side area with two bases that are parallel on either end. Parallel and congruent. So make sure you understand what lateral surface area is. It is the sides, not the bases. You will be asked a question about that in your assignment today. If you're asked to find the lateral surface, just find this outer curved surface. Don't add the bases, right? So how do we find the surface area of a cylinder? So as we saw, a cylinder is similar to a prism, two parallel bases. But the bases are always circles, so that's different than prisms. So the surface area of a cylinder is the same formula as a prism, but because both bases of a cylinder are circles, we can refine this formula. We can write it differently. We can say that a circle's area equals pi r squared. It's pi. And when we walk around the circle's perimeter, we actually call that a C, circumference. We can even revise this formula, excuse me, a little bit, because we know what a circumference equals. And the shortest way to say what circumference equals is C equals pi times diameter. Pi diameter times the height, the cylinder, gives us the lateral surface area. It's the circumference of the base times height. It's a walk around the circle base times height. Okay, so let's try this. Let's find the surface area of a cylinder. And so please draw this figure. And there we go, a cylinder. And when we draw it, we start with the bases. One base we can see, circle. And then across the way, we should try to draw a clone base. Part of it is hidden behind the 3D figure, so we dash it. And then we have the lateral sides. So you could pause the video and try to find the surface area on your own, or if you like, walk through it with me now. So again, we're going to use S to represent finding the whole surface area of the figure. And it equals, as we know, two base areas. Cylinders have two bases. And what shape are those bases? Circles. So the area of each of those is pi r squared. So we write that down. And then we're going to add the lateral surface, right? The lateral surface, we could imagine cutting it right down the top and opening it up is a rectangle. The base of the rectangle would be a walk around the circle, or a circumference, right? So the circumference is pi times d, and then we have the height of the cylinder, height. Now the height of the cylinder, exactly like the prism, is the distance between the parallel bases. So we see it's 60, right? So this is your first step. Second step, we're going to substitute the known information. So let's go ahead and plug things in. So we are told to use 3.14 for pi. So we could write 2 times 3.14. And then what is the radius? Well, the radius is given, isn't it? The radius of our base is given here. It's 2 inches. So we're going to multiply by 2 inches. I'm going to use parentheses here. 2 inches. And we're going to square that radius. So 2 inches squared. Notice that the inches are squared and the 2, right? And then we will add pi. Whoops. Actually, we're going to go ahead and call it 3.14. And now we need the diameter. Pi times diameter. So if the radius is 2, then what would the diameter be across the entire base? Yes, it is 4. So we have 4 inches. And now we need the height of the cylinder, which again is the distance between your parallel bases, which is 60. So we multiply by 60 inches. And we have all of the important facts substituted. So these two lines are the most important lines in pre-algebra this year. Can you come up with the right plan and write it down? Can you follow the plan and substitute the correct information from the figure into the plan, as we did? The final step, of course, is to find the answer. What is the surface area? And that is worth the least number of points. That's really not hard to do at this point. Remember, our order of operations tells us, PEMDAS says, multiply before you add and subtract. So we're going to multiply this group, and we'll multiply this group of factors, and then we'll just add those two products up. So go multiply, come back and write your answer down, pause the video. Okay, and so when we multiply here, we multiply 2 times 3.14 times 4 inches squared, giving us 25.12 inches squared. And over here we have 3 factors, 3.14 times 4 times 60. And now when we add these two together, we end up with 778 and 72 hundredths inches squared. Now, they asked us to round to the nearest inch, so let's do that. When we're rounding, we look at the whole number where we're rounding to and say, does it stay the same, or does it increase by 1 based on its neighbor just to the right? And we can see it does increase by 1, doesn't it? So we have 779 inches squared. Very good. Now, okay, once again, pause the video and give this one a try. See if you can find the surface area of this new cylinder. Come back and we'll walk through it together. Okay, I'm going to try to write again with these pens. I'm not on my smartboard at school, so excuse me for it being kind of not as clear. But anyway, we know the surface area equals 2 base areas, 2 pi r squareds, plus the lateral surface area, right, which is pi d. That's a walk around the base, walk around the circle, and then the height times height to get that entire lateral rectangle. So let's start substituting. We know that I'm going to leave pi as pi right now because both of these terms have pi. This is a little way we can kind of multiply only once later by pi. So I'll show you that in a moment. Radius is half of the 8 centimeters, right? So we're going to plug in 4 centimeters. Half of 8 is 4. And square it. Square that whole term, right? Plus, we have pi times the diameter. And what is it, your diameter? That's right, it's 8. We multiply by 8 centimeters. And then the height, which is the distance between these bases, which is 18.3 centimeters. Okay, so now we simply have to multiply. I'm going to leave pi again as is. Leave your answer in terms of pi for right now. So what is 4 squared? 4 squared is 16. 16 times the 2 is 32. We have 32 pi. Notice that factor of pi is just trailing along. Centimeters squared. Plus, we need to figure out 8 times 18.3. Okay, so we have 146.4. When we multiply 8 times 18.3. And we still have pi, so times pi, centimeters squared. Now, we could right now multiply each of these terms by pi, right? 3.14 times this and 3.14 times that. This is kind of a little shortcut. Because they're both in terms of pi, I have 32 pi's here and 146.4 pi's here. So I simply could just add the two together, and that would give us 178.4 pies. Isn't that cool? So by just adding them, now I only need to multiply by pi one time. Now when we do it this way, sometimes if somebody multiplies by pi on your calculator earlier and rounds it in different places, you may end up with a slightly different answer at the end. But we'll round our answer to the whole number, and I'm sure we'll be in close agreement. So this is the point where we multiply by 3.14, and the answer is 560 and 176 thousandths. So we will round that to the whole number, So what is our answer? That's right, 560 centimeters squared. This would be our answer. I'm not going to try to write it with this keyboard. There you go. So I hope this helps walking through these. Remember, you will have a question today where you're asked only to find the lateral surface. So we only use this lateral part of the formula. We don't include the two bases. And there's your assignment. Good luck.